Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5 want to present about the product to facilitate automation in agriculture, which is 2-in-1 fruit picker. And the group member consists of Muhammad Uzair bin Muhammad Shukri, Wan Muhammad Hafi bin Wan Salihuddin, Nordin Nabiha binti Rosidi, which is me, and Nur Munira binti Muhammad Syukur. Okay, so I will start with the background of design. Okay, so for the problem statement, the current fruit picker had several disadvantages, which is harvesting process take a longer time. There is also a limitation in manual plucking fruit, and it is heavier in weight and less portable, contribute to fatigue. Okay, so for the proper solution, the specialties of 2-in-1 fruit picker are, the height can be adjusted to 7 meter. It has cutter near the other end. It also has a specialized bag to collect the mangosteen fruit, and the pulley is to move the specialized bag, and the height can be adjusted because it consists of adjustable height mechanism, and it comes with lock to make it more stable. Okay, so for purpose circuit market, this 2-in-1 fruit picker is mainly projected to help farmer in Malaysia who own a mangosteen farm, either it is a large, medium or small scale farming. It is also to make fruit plucking work become easier and more efficient, and it can save farmers time as the fruit can be plucked and collected at certain weight at one time. Okay. So for design concept, we have 4 design, which is design A, design B, design C, and design D. And lastly, this is the reference. This is the design reference where its scoring for design reference is 0. So I will pass to my next group member to present about design concept.
Assalamualaikum and hello. My name is Wan Muhammad Hafi bin Wan Salihuddin and my message number is 2022590. So for now, I will continue the presentation with the design concept. So this is our concept screening. There are 9 selection criteria that need to be considered, which is easy operation, cost, weight, fruit condition, cutting performance, ease of collecting, portability, safety features, and maintenance. So all the design discussed earlier is compared to the design reference. Thus, as we can see here, the reference is set to be 0. So after we have done the net calculation, we can find the rank, and as we can see here, design D is rank 1, design B is rank 2, reference is rank 3, design A is rank 4, and design C is rank 5. So from here, design B and design D will undergo further improvement in the concept scoring. As you can see here, this is our concept scoring, and from the design B, we have changed it to be SB plus, where improvement has been made at its telescopic length, which is from 4 meter plus 3 meter to 3 meter plus 2 meter plus 2 meter. Its electric rate is changed to the normal, and the cutter style is changed to be similar as design D, and there's not so much different in design D. So there are top 3 priorities here, which is easy operation consists of 25% of the weight, cutting performance 50%, and ease of collecting 20%. So from our concept scoring, we have done the total rating, and for the design B plus it is 4.7, and for design D it is 4.05. So design B plus is rank 1, and thus we have decided that design B plus is to be further continued and developed as our main design.
Hello and Assalamualaikum. My name is Muhammad Uzair bin Muhammad Shukri and my text number is 202457. So I will present about the design analysis. So some calculation need to be calculated in order to do some analysis. So the first calculation that we made is the cutting force. So to cut the branch of a mangosteen, only around 80 Newton to 150 Newton is needed at the point B, as you can see in the figure, to cut the branches. So we do some calculation about the maximum and also the minimum force needed to cut the branches at the specific angle that is around 220 degree. So after doing some calculation, we get that the minimum force to cut the branch is around 92.736 Newton, and for the maximum force to cut the branch is around 173.8827 Newton. So the next calculation we do is the number of mangosteen that can be fit in the sack. So the sack is expected to be slowly lowered to ground for every 1 kilogram of mangosteen. So the weight of mangosteen is around 80 grams for every average mangosteen. And for the number of mangosteen that can be fit in the mangosteen is around 12 mangosteen. So next for the safety factor of the pole. So the material used for the pole is the aluminium. So the tensile yield strength for the pole is 240 megapascal. So after doing some calculation, we get that the maximum load that the pole can withstand before it bending is 818.4 kilonewton. So next is the fastening end joint. So we need to do some calculation to find the standard size for the for the for the cutter. So after doing some calculation about the reaction force, about the forces at the cutter, we get that the required standard size for the fastener is M3 times 0.5. So next is the fastener end joint at the rail. So the same as the cutter, we do some calculation about the reaction force and the force at the rail, and we get that the required standard size for the fastener is M1 times 0.25. And the last one is the pulley. After doing some calculation, we get that the required standard size for the fastener is M1 times 0.25. So the last one for design analysis is the limit and tolerance. For the cutter, the limit tolerance for the screw at the cutter is 0.012 millimeter, while for the pulley, for the screw at the pole is 0.01 millimeter, while for the wheel axle is around 0.015 millimeter. And the last one is for the rail, and the screw at the pole is around 0.01 millimeter. So that's all from me. I will pass to the Munira.
Now, I am Nur Munira binti Muhammad Shukr with matrix number of 200-259. We will present on our final design of 2-in-1 fruit picker. Basically, the continuous modification in a design is important to lead to a high quality and durability product. So, here is our final design of 2-in-1 fruit picker. The 2D design was created using SolidWorks software. This design came with safety features, which is lock mechanism and ergonomically designed handle. For lock mechanism, it will provide safety and storage, while for ergonomically designed handle, it has anti-slip sponge attached to the handle, which will play a good anti-slip effect when the users use it. Next, choosing the right material when manufacturing a new product is also vital for its success. In choosing material, we must consider a lot of aspects, including the function, durability, aesthetic, consistency of performance, and cost. After doing some research thoroughly, we have finalized the materials that will be used for our components in the final design. For pulley and handle, most of them are made from aluminum alloy. It is light, strong material, hard to undergo brittle fracture problems, and ideal for low temperature applications. For pull, it is made of aluminum also, which has higher oxidation and corrosion resistance. For our specialized bag, the woven polypropylene fabric sack was used. It is stronger than fabric gurney, anti-tear, slash-proof, water resistance, and has a high tenacity. Next, for the split collar lock, it is made of nylon glass fiber. Nylon glass fiber resistance to shocks and high temperature, has a very high stiffness and strength, can operate at a very large temperature range. For the cutter, the blade is composed of Teflon SK5 steel titanium. It is comfortable, light, long-lasting, and offers precise cut of mangosteen stem. For the reel, it is made also from aluminum alloy. It is light, making it easier to reel the rope. Next, for rope, we use solid braid polyester material, which is strong. It is the strongest type of rope, high resistance against rope, and has excellent recovery against stretch and less fatigue. And lastly, the guides, which is made of aluminum oxide guide frame with an aluminum oxide insert. Now I will proceed with the cost estimation. As you can see in this table, the estimated cost of the components give a total cost of 107 ringgit. When it reaches the market, the price might be a little expensive than this estimated cost since there will be a manufacturing cost, labor cost, and other. But still, it could be said that the price of the final design is cheaper and affordable compared to the cost of reference design, which is 99 ringgit, since 2-in-1 fruit picker provide a lot of special features. That's all from me.
Conclusion. In conclusion, there are several recommendations for improvement on future designs. First of all, more creative design should be generated at an earlier stage. Then, costs may be broken down into number of parts, labor required for manufacturing and assembly, raw material costs, and etc. to give a lower price but with high quality of product. Lastly, market research should be conducted thoroughly to determine actual demands of the product. I think that's all from us. Thank you.